On January 10, 1946, a significant milestone in the exploration of space was achieved by the US Army's Project Diana team, when they successfully detected radar signals reflected from the lunar surface. This pioneering experiment marked the inception of radar astronomy and represented the first active endeavour to explore another celestial body through technological means. Project Diana was conceived under the leadership of John H. DeWitt, a figure who initially engaged in the realms of broadcasting and amateur radio after leaving Vanderbilt University's engineering school. His early career included constructing Nashville's first broadcasting station, and later, in 1929, joining the technical staff at Bell Telephone Laboratories in New York City, where he focused on designing radio broadcasting transmitters. Returning to Nashville as the chief engineer of radio station WSM, DeWitt's fascination with cosmic phenomena was ignited by Carl Jansky's discovery of cosmic noise. This led him to construct a radio telescope and to commence searches for radio signals emanating from the Milky Way. The first attempts by DeWitt to use radio signals to study the Earth's atmosphere through lunar reflections began in 1940, but initial efforts were thwarted by insufficient receiver sensitivity. Named after the Roman goddess of the moon, Project Diana officially commenced in 1945, with DeWitt assembling a team that included Dr. Harold D. Webb, Herbert P. Kaufman, E. King Stoddeler, Jack Mofanson, and Walter S. McAfee, who notably calculated the reflectivity coefficient of the moon. To facilitate the reflection of signals from the moon, extensive modifications were made to create a suitable setup at a laboratory in Fort Monmouth, New Jersey. This setup included a large transmitter, receiver, and antenna array. The transmitter, a repurposed SCR-271 radar set from World War II, was capable of emitting signals at 111.5 MHz, generating 3 kilowatts of power, later enhanced to 50 kilowatts in 1/10 second pulses. These were directed towards a bed spring-style reflective array antenna. The echoes from these signals were detected approximately 2.5 seconds after their emission, correlating with the time needed for the radio waves to travel the 768,000 kilometer round trip between Earth and the Moon. The historical moment of the first successful echo detection was recorded at 11:58 a.m. local time on January 10, 1946, a feat achieved by John H. DeWitt and his chief scientist, E. King Stoddeler. The orbital motion of the Moon relative to the Earth, which varied daily, necessitated the adjustment of the receiver to compensate for the Doppler shift in the frequency of the reflected signal. The antenna, limited to rotation in azimuth only, required the Moon to traverse the 15-degree wide beam at either moonrise or moonset for signal capture, as the antenna's elevation was fixed in a horizontal position. This alignment provided approximately 40 minutes of observation time during each pass as the Moon moved through the various lobes of the antenna's pattern. The detection of these radar signals heralded the birth of radar astronomy, which was subsequently employed to map Venus and other nearby celestial bodies. This marked a crucial precursor to the US space program. Project Diana demonstrated for the first time that terrestrial radio signals could penetrate the ionosphere, a breakthrough that paved the way for radio communications with space probes and future human space exploration. The project not only underscored the potential for scientific discovery, but also had significant military implications. It served as the first concrete test of the continuous wave FM Doppler radar, a technology developed during World War II by Edwin Howard Armstrong. This advancement, by significantly extending the signal range beyond that of the then standard pulse radar, facilitated the detection and tracking of potential incoming threats from intercontinental supersonic aircraft during the Cold War era, highlighting its strategic importance.